Having determined the best solvent system to use for a separation, the process can be immediately scaled up to pilot level. At this magnitude, countercurrent chromatography can be operated in normal batch mode, or in certain circumstances, using a non-stop injection of the mixture for a continuous purification process. Taking full advantage of the liquid nature of the stationary phase, the technique being employed here is known as intermittent true moving bed. By flowing the upper phase in one direction, then the lower phase in the other direction, then the upper phase in the first direction again, and so on, a binary mixture can be made to separate into its components. One component will elute with the upper phase at one end of the countercurrent chromatography coil. The other component will elute with the lower phase at the other end of the coil. The mixture can be continually injected into the instrument, and thus it is a continuous purification process. In this case, a mixture of two dyes, one yellow, one blue, is being injected into the maxi centrifuge, dissolved in the upper phase as a green solution. The operator for this process is working from the safety and comfort of a remote operator room, from which he can see all the equipment and control it by computer, without having to handle any unpleasant or dangerous chemicals. A single dedicated software screen shows all the equipment and what is occurring at the time. Whilst still injecting the green mixture of dyes onto the coil at a rate of 200 milliliters a minute, the upper phase is flowed one direction for a period of 2 minutes, then the pump valves switch over and the lower phase is flowed in the other direction for a period of 2 minutes. The two dyes separate, and pure blue dye elutes at one end of the coil, while pure yellow dye elutes at the other end. Of course, a more complex mixture of components requires a batch mode of operation. In one example, the highly polar glucosinolate glucoraphanin was purified from a crude gum, and from the almost identical component glucoiberin by the maxi centrifuge. The injection loading for this separation was in excess of 250 grams per run. A combination of the extremely polar nature of the target molecule and the viscous and insoluble character of the crude gum meant that no suitable preparative method was found with solid phase chromatography, despite much research being done. Fortunately, the maxi centrifuge coped with it all. In just over 8 weeks, including all the sample preparation, analysis, evaporation, and report writing, 2 people managed to produce over 2 kilograms of pure glucoraphanin, the target compound, using the 5-litre maxi at the Brunel Institute for Bioengineering. With an even larger 18-litre super maxi now functioning at the Institute for Bioengineering, even greater injection quantities are possible. And research has shown that the size limit for this technique has not been reached yet. Countercurrent chromatography is an emerging technique of the future, one that is generating considerable interest across both academic and industrial organizations. On the one hand, engineering developments on the old J-type centrifuges have produced robust machines capable of separations which are fast, efficient, and able to accept extremely high loadings. On the other hand, developments in the application of the technique have produced protocols and solvent selection tables that make the determination of the separation conditions and the running of the instruments systematic and simple. Combined, these have produced a technique that is ideally suited to large-scale preparative separations, with advantages over solid-phase techniques, such as the ability to accept particulates, and there being no columns to replace, and advantages over former liquid-liquid techniques, such as the high speed and high resolution. The Brunel Institute for Bioengineering is a financially self-supporting organization working at the interface of medicine, biotechnology, and engineering. Founded in 1983 by Professor Heinz Wolff, the institute is located on the campus of Brunel University in West London. The institute prides itself on its record for enabling technology and its ability to ensure its products are efficiently designed and prototyped, ready for immediate production into the marketplace to benefit the end user. Research into countercurrent chromatography and its applications is a major part of the work at the Brunel Institute for Bioengineering. Scientists and engineers at the Institute have taken the previously unreliable and slow technique of countercurrent chromatography and turned it into a fast, modern, and effective approach suitable for direct scale-up to industrial levels. With 5 laboratories dedicated purely to research into countercurrent chromatography and centrifuges ranging in size from 5 milliliters to over 18 liters in capacity, the scale-up of the technique from milligram to kilogram and beyond has never been faster, easier, or more effective than it is today. Countercurrent chromatography is truly an emerging biotechnology technique of the future.